And now let's look at the other half of this worksheet, quick quad number 8. Number 1, the graph below shows the number of cars assembled last year in 4 cities to about the nearest 5,000 cars. According to the graph, what fraction of all of the cars assembled in all 4 cities were assembled in Coupeville? So once, I guess, it's asking for the relationship of how many cars were in Coupeville compared to the other 4 cities. Well, first, so just want to know the part over the whole. We need to know the whole. How many total cars were there? Okay, we'll give you a key. This one box is 10,000 cars. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90. And it gave you these 2 halves, right? So that means we have 100,000 cars, right? That's in total of the 4 cities. But it wants to know what fraction of the cars were in Coupeville. Well, it looks like Coupeville had 10,000, 20,000, and that's a half, so 5,000. So it had 25,000 cars. Okay, so we have the part over the whole. We got a bunch of zeros here. We can get rid of all 3 of those zeros. So we have 25 over 100. Well, 25 cents in a dollar is a quarter. So we have 1/4. Looks like 1/4 of Coupeville made up the cars assembled. Number 2, points B and C are on the entire line AD. The length of AD, so it looks like this whole shebang here, is 30. AC is 16, so just this little piece is 16. Well, if that piece is 16 and this whole thing is 30, that means CD here has to be 14. BD is 20, right? So this thing here is a 20. Well, by kind of process of elimination, we just found that this guy is 14, but if this whole thing is 20, that means this guy is going to have to be a 6, right? Well, if the whole thing is 30 and I've got 6 and 14, I have 20, what are we talking about, units here, that means this guy has to be a 10. How many units long can be, if it can be determined, is BC. So I wanted this guy right here, which is 6. This is a question, I think it's a lot easier if you have this printed out so you can actually, touch and write on the line. Stuff like this, if you're just using a computer, it can get a little difficult with that. So I don't know, I would probably write out the line with that. So it's just so I can touch and kind of manipulate it. Number 3, what is the x-coordinate of the point in the standard xy coordinate plane at which 2 lines of y equals 2x plus 6 and y equals 3x plus 4 intersect? Well, this goes back to our systems of equations. You're talking about where do 2 lines intersect. So we're 2 lines at the same point in time. So we've got to solve this using a system. Well, you should notice that they are both solved for y. So maybe your Algebra 1 teacher talked about solving by equal value method, or this is just substitution. So I'm going to go ahead and set these 2 equations equal to each other because, again, I want to know when they are at the same point. So I'm going to put them equal to each other. So I want to know when line 1 is equal to line 2. I've got a variable I need to solve. So I'm going to go ahead and subtract 2x from both sides, and I don't think it's too bad. I'm going to go ahead and subtract the 4 as well. So my variable is going to be on the right, my constant is going to be on the left. 6 minus 4 is 2, 3x minus 2x just takes me to an x. And be careful because it will kind of trick you. We solve for x, sometimes, it wants you to find y, but in this particular case, it does want you to find the x coordinate, and that's exactly what we solved for right there. So we know that x is 2. Okay, so just because you solved it, doesn't mean that's the answer they're looking for. Really pay attention to what it truly is asking of you there, okay? And lastly, for all pairs of real numbers m and v, m is equal to 3v plus 6. What is v? Okay, so we got a couple variables here, so it wants us to solve explicitly for the value of v. I'm going to rewrite this m so I can see it on one line. So we got m is equal to 3v plus 6, but what is this equation in terms of v? So basically all it wants you to do is solve for our letter v. So let's get that to a side by itself. I've got this plus 6 on the right with it. I don't want it over there. Pay attention to how you combine like terms, right? That's a variable, that's a constant, you know, just leave it how it is, right? Now we're still left with 3v on the right. These guys are stuck by multiplication. Remember, anytime we multiply or divide an equation, everything must get multiplied or divided through by. So those 3's are going to go away. My v, I have m minus 6 over 3. And actually, that's one of the answers. We didn't even have to simplify that at all. Okay, so it looks like our answer is D there.